Let's start with 1.5, number 58. And it's because it's, let's just do it this way. Number 58 is x squared minus 4x plus 2 equals 0. Nice and yellow. It's because of the bulb is being the way it is. Okay, this does not factor. Factors of 2 do not add up to 4. Okay, so what you have to do to complete the square, again, it's the process. You need to have this part all by itself, and if there is a third part, it needs to be on the other side. Okay, so we call this c for constant. It really comes from ax squared plus bx plus c. So I'm going to start using a, b, and c to reference those types of terms, okay? So we need to move c to the other side if there is a c. So x squared minus 4x equals negative 2. All right? So this is how it's supposed to look to complete the square. So you need to make whatever it is that you've been given look like this. The next thing is you take b, positive or negative, and then you're going to divide it by 2, and you're going to square it. What happens when you square a negative? It becomes positive, right? So what you're going to be doing is you're going to add b over 2 squared to both sides. You can't just add it to one side, so you have to add it to both sides. So completing the square is just adding b over 2 squared to both sides. So write down those words, whatever it takes for you to go back and make sure you can do it. Because this is an Algebra 1 problem. Obviously, we got to get to a pre-calc problem. And there's lots of different ways, or not lots of different ways, there's a couple different versions of how we use completing the square. So we really need to understand what it means to complete the square. What you are doing is you're creating a trinomial that is factorable then. So just to show you, we have x squared minus 4x plus what? That'd be 16 over 4, which would be 4. Okay, and then on the right side, so this is 4. So negative 2 plus 4 is 2. Okay, so this is factorable. What do you get?
X minus 2.
Now we got to solve this. Ready? Notice that these two are the same binomials. Does anybody remember completing the square? When you complete the square, these are going to be the same. There's 2 of them. If they're not the same, then you did something wrong when you set it up. Now, how do I solve that? Now, does it look familiar algebraically? How to solve? Yeah. And this is every time that you're solving by completing the square. So then you have x minus 2, 1x minus 2, equal to 1.4. Right? Hello. 1.4. It's close enough. Whoops. So add 2 to that. And it's plus or minus, by the way, from here on out, unless I say differently. So add 2 to that, you get x equals 2 plus or minus 1.4. So your answer is 3.4 or what's 2 minus 1.4? 0.6. So that would be your answer, your solution. So now I'm going to use this problem to point out a couple things. All right? So how do we complete the square, first of all? Repeat to me just the basic part of it.
B over 2 squared added to both sides.
Yep. B over 2 squared out to both sides. Doesn't matter what your sign is because when you square it, it's going to be positive, right? Okay. You got to get that because that's the mistake everybody makes. They put minus signs in where they shouldn't. All right. Now, you should end up with, 2 of the exact same binomials. How do you actually get these things? Here's what you do when you complete the square, because it's not going to be trinomials that you know how to factor. So you're going to need to know how to write down the answer, even though you don't know what you're doing. Does that sound familiar? Every night, right? This first letter is the first letter of your trinomial. The sign that is in between both of your binomials will be the first sign in the trinomial. And the number that's in your binomial is whatever b over 2 is. Without the plus, positive or negative, okay? Because we're going to start to take away the easiness of factoring. And if you can remember those 3 things, then you can get to the last step. You take b over 2, you square it, add it to both sides, write down the first letter, write down the first sign, and write down whatever b over 2 is in your binomial. And that's the factored form. All right, so let's go on and do a another problem here. Let's do number 64. This is really ugly. I don't think I've ever done this one. X squared equals 3/4 x minus 1/8. Welcome to fractions. We're all happy, right? Now, you could get rid of your fractions, which is what you did yesterday, right? So I'm just going to, and you can do that. I want to use this to show you how to do completing the square when you have fractions and you don't know what it factors into, okay? So I need to have the ax squared and the bx on one side. So I need to put this back over here to get it in the correct form to complete the square. Do not drop that negative sign on the 1/8. Okay, so this is how you have to get it set up to complete the square for now, okay? So I'm going to ask you, first of all, what is b over 2? Somebody rattle off what you're supposed to do at this point. Top times, you said it. You just said it weird. Top times the reciprocal of the bottom. Okay? So take 3/4 times the reciprocal of 2, and what do you get? What? 3/8. Okay, so that's b over 2. So we're going to add b over 2 squared to both sides. Because you all said that's how we complete the square. You repeated that to me. b over 2 squared added to both sides. And now you're looking at that going, I don't know how to factor that trinomial. So what's the shortcut I said? First letter, first sign, and b over 2. Even if you got rid of your fractions, I mean, you could factor it and you'll eventually get the correct solution if it factors, which is what you're trying to create here. But I'm using this problem just to show you how easy it is just to put everything in place with a shortcut. Now the question is, what's on the right side? Negative 1/8 plus 9/64. So we got to multiply by 8. So that's negative 8 plus 9. It's positive 1/64. So that's going to be the right side. So we'll go ahead and solve it just to finish it. But let's stop for a second, make sure you're caught up and understand what we're doing. I'll pause this. So let's go ahead and we're going to take the square root of both sides, right? What's the square root of 1/64, please? Square root of 1 is what? 1 square root of 64? Okay, so the right side you have plus or minus 1/8. The left side you have x minus 3/8. So you have 3/8 plus or minus 1/8. Doesn't that look easy? Now, 3 plus 1 is 4, 4/8 is 1/2, 3 minus 1 is 2, 2/8 is 1/4. So that would be your those would be your two solutions. All right, so that's completing the square. It's not in here. Okay, we'll do quadratic formula probably tomorrow, Tuesday. So let's stop there. So your quiz tomorrow will be what you did yesterday. I'm going to give you just a couple extra odd problems for completing the square to work on tonight. And then your quiz will include completing the square and what you did yesterday. So I will answer questions from yesterday's homework. If you've not turned in your homework by now on Google Classroom, then you will not be getting credit. Just as if I walked around at the beginning of the day, okay? First of all, let's see here. So we have Haley, homework. Yep, homework problem questions, is that what you're looking at? Okay, so you're gonna ask me about some of those? You have your hand up first?
Yeah, 27.
3, yeah, 27? Let's do 27. All right, number 27. Let's just continue this on here. Go through it. So everybody's gonna do well on the quiz tomorrow, right? All right, 27 is 3 over x plus 1 minus 1/2 equal to 1 over 3x plus 3. All right, did you start it? Yes or no? Did you start it?
Yeah,
Okay, what did you do?
I took all the bottoms and combined it since they didn't have like.
How did you do it? How did you do it? I mean, did you multiply everything by a common denominator, or did you add and subtract fractions by getting a common denominator?
I multiplied all those numbers by the denominator.
Okay, so you multiplied x plus 1 by what? So you factored a 3 out first?
Yeah.
So all your factors here are x plus 1, 2, and 3. Those are all your factors. Okay? I would remove all my fractions. Is that what most of you did? Or did you add fractions together? Okay, let me show you what I would do, and if you want to do it a different way, I'll do it a different way, okay? So this, the first term has x plus 1, so we need to multiply that by 2 times 3, or 6 if you want. So I'll just write 2 times 3 just to keep it consistent. And x plus 1, because I want, I'm sorry, hold on a second. Let me erase that. I'm multiplying by all the factors, so the denominator reduces out. So if I do it this way, the x plus 1 reduces out, and I'm left with 18 on the top. Now the minus 1/2, if I multiply by the x plus 1 times 2 times 3, the 2 will reduce out and become 1. And then I'm left with what? What'd you say?
3x plus 3.
Oops, not equals. This is a minus sign here. So it should be a minus 3x minus 3, and then our equal sign. And on the right side, we're going to multiply by 3 times 2 times x plus 1, because those are all our factors.
How'd you get a minus 3?
You got to distribute that minus 1 through the whole part, the whole top.
So that wouldn't it just be 18 plus 3x minus 3? After you would distribute the negative?
Yeah, after you combine the 18 and the minus 3. So this is going to be a negative 3x plus 15. You have to distribute the minus 1 because it's minusing that whole group. And you were right, it was 3x plus 3 on top, but you gotta distribute that minus sign through. All right, so on the right side, the 3's reduce out, the x plus 1's reduce out, and I'm left with 2 times 1, which is 2. Okay, subtract 15, negative 3x equals negative 13, x equals 13 halves, or 6 1/2. Sorry. First mistake all year, right? So 13 thirds. So you get 4 1/3. Thank you. We got our 2 times 3. You're talking about that part?
Like where you multiplied the fraction.
Right. Okay, so what factors are there in your denominator? We have an x plus 1, we have a 2, and we have a 3 times x plus 1. So all of our factors are 2, 3, and x plus 1. So if you list all your factors and multiply by all of those, your denominators will reduce out. So that's where the 2 times 3 came from. Hold on a second. So are we done with this problem? Okay, what was your question?
I just wanted you to write out the completing the square formulas.
Oh, the formula?
Yeah.
Yeah. So the formula for completing the square real quickly is going to look like this. ax squared plus bx. And you're going to put c on the other side. I put minus c because in the formula it's plus c. Whatever it is, you move to the right side, okay? And so this part is your completing the square. B plus b over 2 squared. And then after that, you factor the trinomial.
Thank you.
Wait a minute. A has to be 1. If it is not, I would suggest you divide by whatever A is before you start. And there you can imagine that you're going to end up with fractions because you're dividing that off. Okay? But this is a must. Otherwise, it just isn't going to work right. Okay? Next question.
No, I just
Okay. Was that okay for now?
Yep.
Okay. 41, you want to see?
Yes.
All right. All right. Let's write this down. Okay, so a squared plus b squared equals c squared. All right, so we have the Pythagorean theorem, and we're solving for b. Okay. What did you do to start?
I moved the a squared over the c squared.
Okay, so b squared equals c squared minus a squared. And then what?
And then I squared both sides.
Okay. Done.
So why doesn't the c and a just go c minus a?
Okay, so real quickly, a fast answer. What is, let's see, how can I do this? Let's do 16 plus 9. So technically, this is the square root of 25, which is 5. If I take the square root of 16 plus 9 and say that that's 4 plus 3, does that equal 5? So anytime, again, whenever you have plus and minus signs in between things in groups, like in your denominator or in the numerator, you can't reduce pieces and you can't take square roots of pieces either. So pieces means you have more than one term in that group. It doesn't work, okay? But if it's all multiplication and division, then you can reduce things out. You can take the square root of individual things, but you can't do that with pieces. All right? Another question? 51. All right, do we feel a little bit better? We need to do a couple more. Build some confidence. All right, nobody's talking to me today. I make one mistake and you guys are flipping out. All right. So it's already ready to, what are we doing here? We're solving by factoring. And I want to tell you something. You can solve most of these things by completing the square as well. Usually algebra students, once they realize how to do the quadratic formula, they stop factoring and they just use the quadratic formula because the quadratic formula will work on all factorable trinomials. Completing the square is the same type of thing. If they're not factorable, you can complete the square and make them factorable. That's the purpose of completing the square. Okay, so 51 is not in the section of completing the square, so we're going to solve this the other way. So let's go ahead and make it a trinomial. I should ask you, what did you do? Who asked this question?
Oh, I did.
Okay, what did you start it at all or weren't sure what to do?
I don't even know.
Okay, well, what you should have done at this point is try to make it a trinomial to see if it factors. Okay, so factors of 3 again to help you out that are still struggling with this. Factors of 3 are 1 and 3. I always put the bigger factor on the left. You don't have to. Factors of 2 are 1 and 2. Again, I'm randomly putting these in here until we can start making some good guesses. So you check the middle, that's 1. You check the outside, that's 6. How do I use 1 and 6 to get positive 5? So negative 1 and a positive 6. Okay, so put those signs up there. So negative 1x and a positive 6. I'm sorry, the blue is not showing up very well on there. And then check again these values. Does a negative 1 times a positive 2 equal a negative 2? Okay, then yes, you did it right. So now the question is, what are your solutions? So if we're still struggling with that part, you're supposed to set each parentheses equal to the 0. 3x minus 1 is equal to 0, or x plus 2 is equal to 0. Again, you can use the shortcut, but the shortcut is based off of this right here. Add 1 and divide by 3. And subtract 2. So that would be your solution to the problem. This is good. So let's do some more problems. And if you're done asking questions, I'll pick some, and we need to practice doing some of those fraction things.
Will you do one like 27?
Like 27? Yeah. How about yeah, a lot there. Did we do 20? We did 20 in your notes, 24 and 28, or
Yeah, we did.
we did 26 and 28?
Yes. 20, 24, 26, and 28.
Oh, okay. Well, let's do. There isn't another example that has letters in it. Let's see if I can find another one. We can make one up. We can make one up. How's that? If we make it up, that doesn't mean the solution is going to be nice and neat, okay? So let's do, let's see if I can trip you up a little bit.
No, we don't need that. I don't think so.
Well, it's going to be like 27, okay? Okay, so how about we do 2 over x minus 1 minus 3 over 4 equals 4 over 2x plus 3. Yeah, so this solution is going to be kind of crazy. But these are all the same process.
Okay.
So if we want to get rid of our fractions, which is what I would do, what do?
You multiply the 2 by x plus, or x minus 1.
What are all your factors? Let's do that.
X minus 1, 4, 2x plus 3.
Are any of those the same?
No.
So to remove fractions, you multiply by every factor. So if we multiply, let me erase this top part here. If we multiply this by x minus 1 times 4 times 2x plus 3, then the x minus 1s reduce out. So now you have to do that.
So 8
16x plus 24.
So 2 times 4 is 8. Distribute the 8. 8 times 2 is 16. And 8 times 3 is 24. I took the 2 times the 4. This is all multiplication, so I can take 2 times 4 first if I want. And then I distributed the 8 to 2x and got 16x. And 8 times the 3 is the 24. However you want to do it, just make sure you get 16x plus 24. And then you're going to multiply the 3 by x minus 1 times 4 times 2x plus 3, all the factors again. And what happens? The 4s will reduce out, and now you're going to have an ugly trinomial. So let's write this down here. First of all, x minus 1 times 2x plus 3. Let's do that. So FOIL, distribute, whatever, and you get 2x squared plus x minus 3. Except now what do you do? Distribute a negative 3 through this. I'll scroll back down here in a second. Let's just go ahead and do this. Oops. Oops, that's not right. Told you it'd be ugly. And then the right side, you got to multiply by the same thing. X minus 1 times 4 times 2x plus 3. So there's a reason we don't combine those terms to get those factors together. We want to notice what reduces out. So now you have 4 times 4 is 16, and distribute that through there. And we're not going to solve that. This is going to be an ugly answer. The point is, can you get to that spot?
Maybe.
Yeah.
Okay, so on 27, why
Mhm.
did you do 3 as a factor?
On 27,
And then you did like the x
Where's it
plus
at?
3, but on that one you only need 2
oh,
x
there it
plus
is.
3.
Oh, because the 3x plus 3 here, we could factor out a 3. And that was 3 times x plus 1. But we already had an x plus 1 listed, so we don't need to list it twice. So that's where that 3 came by itself. Okay? All right. All right, so let's just see if you really do get this. Let me give you a simpler version of this and see if you can work it out. Okay? Let's do 1/2 minus 5/6 equals negative 4 over x.
First one, 1/2.
Well, oh yeah, 1 over 2 minus 5, thanks. Minus 5 over 6 equals negative 4 over x. Example 2. So I want you to remove your fractions for practice and then try to solve it, or at least get it down to close to being solved. I know you could take 1/2 minus 5/6. I want you to practice getting, remove your fractions. Correctly. So what are all your factors? Okay, so if you said 2, 6, and x, that's okay. But you should also realize that 6 is the same thing as 2 times 3. Okay? So you can do 2, 6, and x. It's okay. You're just going to have probably reducing to do later. So all our factors really are 2, 3, and x. Okay? So if I multiply everything by 2, 3, and x, or 6x. The 2's will cancel, and I'll get 3x for the first term. All right, so the 2 and the 3 will reduce in the second term, leaving 5x. The x's will reduce out in the right side, leaving what? So 3x minus 5x is minus 2x. Divide by negative 2, and you get positive 12. That was total luck that worked out right. So when we make up our test, when we make up problems, we actually go through a few different scenarios until we find one that is nice and neat. But you could have added or subtracted 1/2 minus 5/6 first and then gone from there. All right. So the reason I put 2 and 6 in there is to see if you understood the factors. Any other questions?